Welcome to section 12.2, surface area pyramids. We're going to find the surface area and lateral area of pyramids. For homework, we're going to work on page 567, numbers 1 through 8. So like in the last section, before we begin, we have to talk about some vocab words. The first vocab word is a pyramid. Now, a pyramid is a polyhedra with one base. A regular pyramid is a pyramid whose base is a regular polygon. Now, some important ones. The slant height. The slant height is going to be the height of the slanted triangle sides, whereas the height of the pyramid itself is the perpendicular distance from the top of the pyramid to the center of the base. So now we have some formulas associated with pyramids. Now, these formulas can only be applied when our pyramid is regular. So in other words, it has a regular base. The lateral area is 1/2 p times a little lowercase cursive l, where p stands for the perimeter of the base, and that little cursive l stands for the slant height. The surface area is the lateral area plus the area of the base. Now again, it's important that you only apply these when you have regular polygons, equilateral triangles, squares, regular hexagons, regular octagons, so forth and so on. Now we come to our first example. We're going to find the lateral area and surface area of our pyramid. Now, the first thing we have to ask ourselves is this pyramid regular? And yes, it is. It has a square-shaped base, even though it looks kind of like almost like a rhombus or a parallelogram. It is going to be a regular base. So we can apply our formulas. The lateral area is going to equal 1/2 the perimeter of the base, 10, 20, 30, 40, times the slant height. The height of the slanted triangle, which they gave us, is 12. Half of 40 is 20, and 20 times 12 is going to end up giving us 240. Now the surface area. The surface area is going to be the lateral area for 240 plus the area of the base, length times width, 10 times 10, which is 100. So the surface area is going to be 340. Now for our next example, again, we're going to find the lateral area and the surface area. First off, we want to say, is the base regular? And it's definitely not. It's not equilateral. So instead, we have to think about what other ways can we find the lateral area. Now, remember, the definition of a lateral area of any polyhedra is going to be the area of the lateral faces. In other words, the area of those triangular faces, all the faces except the base. So let's see, if we have a rectangle here, which faces are going to match up? We should have the front and the back triangles are going to match because opposite sides are congruent. The left and the right are going to match as well. Now, I'm going to take that triangle, I'm going to draw it out, and I'm running into a big problem right off the bat. All I know is the side of 8, and on those front ones and the back one, the side is 6. I don't have a height here, nor do I know what my other sides are. But instead, they gave us the height of the pyramid, which for our purposes right now is useless. What I know, though, is it does hit the center of the base. So what I'm going to do is I'm going to form a triangle. Now, when it hits the center of the base, a right angle is always going to be formed. Now, I'm going to draw in the height. Now, hitting the center of the base is the halfway point, so we're halfway across. We know the total distance across is 6, so here we have 3. So here's what we're looking at. That inside triangle is a right triangle with sides 3 and 3. It's isosceles and right, making it a 45, 45, 90. If across from 145 is 3, across from the 90 is going to be 3 root 2, which is going to be this piece right here. And that's going to be the height of that left and that right triangle. Now, I'm going to actually erase this so we can see what else is going on. That's all well and good for that, but now we also need to know what the height is of my front and back triangle. Now this one looks a little bit more awkward when I draw it. But I'm going to draw the height there, and I'm going to connect it to where the height hits the center of the base, which is the halfway point going up and down. We know the total distance is 8, so we have a 4 here. And a right angle is formed where that height is hitting the base. It's an altitude. So that inside triangle here actually has a side of 4 and a side of 3, and we're looking for the hypotenuse. Remember, anytime you do know 2 out of 3 sides, you can always Pythagorean theorem it. 3 squared plus 4 squared equals x squared. And some of us figured out that pattern. We have a 3, 4, and across from the right angle is going to be 5. If not, 9 plus 16 equals x squared, 25 equals x squared, and square root it. What we do know then is that the height of this triangle with base 6 is going to be 5. So here we go, that lateral area. We need to add up the front and the back, which should match, the left and the right. So here we go, the front and the back triangles. 1/2 base times height. Half of 6 is 3, and 3 times 5 is 15. 15 plus 15 plus my left and right. 1/2 my base 8 times my height 3 root 2. Half of 8 is 4, and 4 times 3 root 2 is going to give me 12 root 2. Simplify that, and the lateral area of this pyramid is going to be 30 plus 24 root 2. Now my surface area. Surface area is all the surfaces, which includes those 4 triangles, which would be my lateral area. 30 plus 24 root 2 plus the area of my base, which is a rectangle, length times width, or base times height, which is 6 times 8, which is 48. Combine your like terms, and the surface area is going to give you 78 plus 24 square root 2. Now, I know how much you thoroughly enjoyed doing it when it wasn't a regular base, but let's get back to the regular bases. Here we go. Now this one is a triangular based pyramid. It looks kind of awkward, but that triangle right in here is actually going to be your base. So here we go. We know it's a regular triangle because all my sides are equal, therefore all my angles are going to be equal. We also have a slant height here. Now since it's a regular pyramid, we can apply our formula. Lateral area is 1/2 the perimeter of the base, which is 18, times the slant height, the height of that slanted triangle, which is going to be 5. Half of 18 is 9, and 9 times 5 is 45. Now my surface area takes that lateral area, and we add the area of the base. Let's take that base and let's draw it out. It's equilateral, therefore it's equiangular. So I need to find out what my height is. So we're going to create a 30, 60, 90, which splits my base into 3 and 3. Across from my 30 is 3, across from my 60 is 3 root 3. Area of that triangular base. 1/2 my full base, which is 6, times my height, 3 root 3. Gives me a surface area of 45 plus 9 root 3. Half of 6 is 3, times 3 root 3 is 9 root 3. So here's our last example. I want you to find the lateral area and surface area of this pentagon pyramid. Press pause. Let's see what we can do. So here we go. We can use our lateral area formula here because we know that we have a regular polygon. Lateral area is going to be 1/2 the perimeter of the base. We have 5 sides, a 10, so 50, times my slant height. Don't got it. What we actually have here is our lateral edge. I actually want to draw in my slant height, so I'm going to draw it in red so we can really see it. Here's my slant height. Anytime we have a height, it forms a right angle with whatever it hits, whether it's the height of the pyramid or the slant height. So here we go. If all my sides are 10, we know this is going to be isosceles. All my lateral edges are going to be congruent. So it splits my base into 5 and 5. So we're going to do Pythagorean's theorem. X squared plus 5 squared equals 13 squared. Some of us figured out this Pythagorean triple as well. It's a 5, 12, 13 triangle. Or let's continue. X squared plus 25 equals 169. Subtract your 25. X squared equals 144 and square root it. X is going to be 12. That's my slant height. So here we go. Half of 50 is going to be 25, And 25 times 12 is going to give me 300. Now my surface area. Surface area takes that lateral area and adds on the area of my base. My base here is a regular polygon. 1/2 the perimeter, which is 50, times the apothem, which I give you, which is 4. So let's go ahead. 300 plus 100 is going to give me 400 for a surface area. Last but not least, we have our homework answers. Again, our homework is on page 12.2, or section 12.2, numbers 1 through 8. If you have any questions, please feel free to ask, and as always, have a good one.